Hello fellow classmates, this is my fifth take of this video because I can't seem to keep it under 10 minutes. So I'm going to try and do it in 4. This is my project. It's a synthesizer and you can control it with a thing called a LeapMotion, which is this. It tracks the movement of your hands over it like this, and it can sort of see the tip position and velocity of all 10 of your fingers, or 5 in this case because the other 5 are busy holding this phone. And what I made is basically a synthesizer. So, like a piano, but you can actually contour the sound yourself using awesome things like not crashing. So, I will show you in a brief moment that you can navigate throughout the interface using a series of gestures. As you can see, it's got one finger showing. That means you're in navigation mode. So I can move around the select cell by swiping in a certain direction. And I can change the value of any of these by showing it 3 fingers and moving up or down. Some things move smoothly like dials, and some things like buttons have a threshold that you have to cross to turn them on and off. And these control what's called the ADSR envelope of the sound. So that's how it turns on, how it stays on, and how it turns off. This over here controls the fine tuning. So if you like things being out of tune, that's your guy. This controls the harmonic, and this controls the volume. This is the harmonic chart. You can draw it by showing it 3 fingers and sort of sculpting in the sky what you want it to look like. If you've never seen one of these before, I wouldn't worry too much about it because it's a little daunting to learn about. Each of these are called harmonics, and they are multiples of each other. And the height is done logarithmically because why not? And they add up to make a sound. And all sounds are sort of a combination of series of sine waves. So over here we have another oscillator, which we can also change values of and stuff. And if we turn it on, it will also add to our sound. Unfortunately, I haven't been able to turn on too many because a single sine wave has to be sampled 44,000 times a second in order to produce sound. So as you can imagine, that many sine waves has to be calculated an even larger amount of times, even with lookup tables and stuff. So I try to keep it pretty minimal. Let's see how this goes right here. So what I'm going to do is I'm going to show it 5 fingers over this for about 70 milliseconds, and the keyboard will turn on. And that's this guy right here. So as you can see, there are certain keys that are sort of lighting up. That's because I'm hovering over them. And as I get closer and closer to the threshold, which is a vertical threshold about 200 millimeters off the ground, they get brighter and brighter until they make noise. So the point at which I cross them is at the threshold. Oh, and it made everything explode. Cool. Let's do that again. So now we lost our interesting sound, but that's okay. We'll get a nice pure sine wave. Here's what that sounds like if you've never heard it. Neat. So you can play this like a piano. So I can show it 3 fingers and kind of just plop around with chords and stuff. It takes a little getting used to because obviously it's in the air. But yeah, it's a fun little instrument to play around with. I'm hoping to add other features, like it'll be able to detect whether you're moving your hand forward or backwards, and you'll be able to kind of alter what that changes, and you'll be able to smoothly sweep between pitches, so things that pianos can't do. I really want to take advantage of this 3-dimensional vectoral space that this has, because designing stuff around it is not as complicated as you would think. So I'm sure you can get lots and lots of musical expression out of it, which is cool. So that is my project. I hope you liked it, and yeah, have a wonderful final season.